In Part 3 of Lecture 1, we will discuss historical perspectives on operating systems. Atlas was an early operating system developed at the University of Manchester in the late 1950s and early 1960s. It included certain revolutionary features that have since become standard operating system features, including device drivers and spooling. But the most important feature employed in its design was demand paging. Magnetic core memory was first being used at the time. It was much faster than drum memory, but still very expensive, so computers did not have a great deal of it. The Atlas system stored most of its memory contents on drum memory, but used the core memory as a cache, saving the most recently used pages of memory in core memory. As new pages were needed, it would load these into core memory, rewriting the pages that were replaced on the drum. This is a model for most modern virtual memory systems. THEE was a batch system developed in Eindhoven by Egster Dijkstra and others in the 1960s. It was implemented on the Dutch computer ELX8. It had a clean design using a layered approach. It used a process approach to design, with the operating system function as a set of coordinated processes. Additionally, it created 5 user processes to compile, execute, and print user programs. The most significant feature of THEE was the use of semaphores to coordinate the activities of the concurrent processes to maintain the synchronization of various activities. Dijkstra borrowed the concept from railroads, which used flags to coordinate trains sharing the rails. Semaphores remain a heavily used concept in the design of most operating systems. Batch systems are not particularly convenient. On busier systems, like the one I used as an undergraduate at Columbia, you could wait anywhere from 5 minutes to several hours for output. And while this is not a problem for production runs of certain applications, it is a royal pain when developing programs. And for some applications, it makes no sense at all. Imagine if the ATM told you to come back in 2 hours, because the mainframe was not ready to process ATM withdrawals. Time-sharing systems used terminals and took advantage of the fact that input at a terminal was much slower than the CPU. Each user had a small slice of the CPU's time, and when that time was up, the CPU went on to work on someone else's job. And if you didn't have too many users, it created the illusion that it was working on everyone's program at once. By nature, time-sharing systems are more complex than batch systems, and for this reason didn't become common until the 1970s. But once they became practical, they replaced batch systems for most applications. It shouldn't be surprising that the interactive nature of batch systems become the model for computing on personal computers. The first practical time-sharing system was CTSS, the Compatible Time-Sharing System, which was developed at MIT in the early 1960s. Although its capacities were limited, it could actually support 32 users at the same time, and demonstrated that interactive computing was practical. CTSS was still in use as late as 1972. MULTICS was a product of CTSS's success. CTSS proved so successful and so popular that MIT sought to create what would be a time-sharing utility. This required a bigger computer and an operating system that could support more users, because they wanted to be able to provide computing services the way the telephone company provided phone service. MULTICS ran on a redesigned General Electric 635, which became known as the GE 645. The machine used a page segmentation memory system, a sophisticated memory management scheme, and a multi-level queue for scheduling CPU time. And the whole thing was written in PL1, all 300,000 lines of it. AT&T was also involved in MULTICS development, but dropped out in 1969. After AT&T dropped out of the MULTICS project, Ken Thompson of AT&T Bell Laboratories considered various changes he would have made in MULTICS design. He quietly started work on Unix, using a PDP-7 left over from the MULTICS project. Ideas were borrowed from other systems, including CTSS. Eventually, this was rewritten for the PDP-11/20, a machine which was purchased so they could create a typesetting system for Bell Laboratories' patent department. For the third version, Dennis Ritchie developed the programming language C, based on an earlier language called BCPL, or B for short, and later it was implemented on a PDP-11/45 and PDP-11/70. As an undergraduate at Columbia, I had the opportunity to work on the first Unix computer system outside of AT&T, but I don't think that I really appreciated that fact at the time. Unix, in addition to becoming fairly popular in its own right, and in addition to becoming the most common operating system for workstations and the original platform for the Internet's TCP/IP, has influenced virtually every major operating system project since the 1980s. Believe it or not, the microprocessor was not developed so people could build computers from them. They were developed so people could build pocket calculators more easily. Later, after the MITS Altair was built and people literally lined up to buy them, other companies started to follow suit. Incredibly, Hewlett-Packard had the opportunity to own the rights to the original Apple computer and signed them away for free. After the Apple computer found its way to some parts of corporate America, IBM eventually got into the act as well. Since they were looking to get into the market as quickly as possible, they went to Intel for the processor and Microsoft for BASIC. Microsoft eventually bought the rights to Seattle Computer Products' disk operating system. This eventually became MS-DOS. Like most early operating systems for small computers, DOS was essentially a program loader, which provided a simple interface for the user and a basic file system. DOS provided no protection features because presumably everyone would want to monkey around inside their own computers. While this may have been a good idea, it led to the creation and proliferation of computer viruses, which remain a problem to this very day. PCs eventually became more powerful, incorporating many features of larger computer systems, including the ability to run more than one program at a time. As a matter of fact, some people called the 386 a mainframe on a chip. Imagine what they would say about the Pentium 4, not to mention the more recent duo and quad-core processors. MS-DOS's abilities were fairly limited, even with the release of Windows to provide a graphical user interface. Microsoft worked together with IBM to develop OS/2, a multitasking operating system to replace DOS. But given Microsoft's dissatisfaction with the design, they developed Windows version 3 to incorporate multitasking of both Windows and DOS programs. Later, they released Windows 95 and 98, which used the full 32-bit capability of what were then current Intel processors, and unlike Windows version 3, was a true operating system in its own right. In the 1980s, very powerful desktop machines were developed, which rivaled the power of mini-computers of their day. These became known as workstations and started to appear in labs, engineering departments, and on Wall Street. Most of these computers used various versions of Unix, which helped increase its popularity.